All right, Pre-Calc GT peoples, let's talk about trig function values. This is going to be crazy similar to what we did the very first unit. If you remember way back when we talked about cosine s, and I asked you like cosine pi over 4, cosine pi over 6, cosine 17 pi over 2, all of that. Well, that was when pi over 4, pi over 6, all of that represented an arc length. That is the exact same thing if I asked you the cosine of pi over 4 or the cosine alpha in radians, as well as the cosine of alpha in degrees. So, example, I could say the cosine of pi over 3 is the exact same thing as the cosine of pi over 3 radians or the cosine of 60 degrees. So you might be wondering, what is different? Well, when we first started, we looked at what was called circular functions. The only difference now is these are trig functions. But the values that you get, whether you're dealing with degrees or radians, are going to be the exact same value. For instance, let's evaluate. Well, let's take a look at the sine of 60 degrees. Now, 60 degrees is a unit circle value. In fact, you could say, oh, that's the exact same thing as the sine of pi over 3 radians, which is the exact same thing as the sine pi over 3 from the good old unit circle that we fell in love with the first week of school. And you answer me and you say, that is root 3 over 2. Exact same thing. We're giving the exact value, not a decimal. This is not our calculator. So now the cosine of 135 degrees. Well, 135 degrees falls in what quadrant? 2. And in quadrant 2, cosine is negative. So that's the same thing as the negative cosine of 45 degrees. If you wanted to think in terms of radians, that's the negative cosine of pi over 4 radians or negative 1 over root 2. So far, so good. Yes? Fantastic. 3. Let's look at the tangent of 840 degrees. Okay. First thing you need to figure out is, where does the tangent of 840 degrees lie? Well, you could think about the coterminal angles that you just quizzed on and subtract multiples of 360 from 840. And when we do that, you find that the tangent of 120 degrees is the least positive coterminal angle to 840 degrees. Well, 120 degrees is in quadrant dos, very good. And that's the same thing as the negative tangent of 60 degrees. If we put it in radians, 60 degrees is the equivalent of pi over 3 radians. And if you forget, you can always put it back in terms of sine and cosine. But the tangent of pi over 3 is root 3. So now we have negative root 3. Questions so far? Make sure you write them down and bring them to class, because we will certainly go over it. Why don't you try numbers 4, which is the secant of 900 degrees, and number 5, which is the sine of negative 150 degrees. Go ahead, pause the video, and then answer these 2 questions and come back and keep checking. Let's go over the answers. Secant of 900 degrees. Well, I'm going to subtract 360 as many times as I need to get to a number between 0 and 360 to find the least positive coterminal angle. That's 180 degrees. That's the same thing as thinking in terms of secant of pi radians. Secant is 1 over cosine. Well, what's the cosine of pi, or the cosine of 180? Negative 1. And 1 over negative 1 gives us just negative 1. Negative 150 puts us in quadrant 3. Negative 150 is the same thing as the negative sign of the 30-degree angle. That's in quadrant 3. Or if you prefer to think in radians, that's pi over 6 radians. And the sign of pi over 6 is 1/2. So you should get negative 1/2. Alright, hopefully this is feeling very similar to you. Very easy, because now we're going to talk about the calculator. So when we first did stuff on the calculator, we were in radian mode. Now you're going to have to be very careful to check the mode that you're in. Some problems we do in degrees, some problems we do in radians. Okay, so let's take a look at our first example, which will be the cosine of 28 degrees and 12 minutes. Remember that little tick mark means minutes. 1 minute is 1/60th of a degree. You could also think about it in terms of 6 minutes is 0.1 of a degree. But lucky for us, we can actually do minutes on our calculator. Okay, so what you're going to do is on your calculator, first of all, check and make sure that you are in mode degree. It's slightly disappointing that I can't show you the beautiful screen of my calculator on this thing, but we're going to make do because you have yours in front of you. So you're going to hit cosine 28, and if you hit second apps, that'll take you to angle. 1 is a beautiful degree symbol. Then you can hit 12, go back to second apps, and 2 is our minutes. You can close your parenthesis for cosine, type it in, and you should get 0.8813 approximately. Now you're probably always wondering, what are we doing when we're taking it to 2 verse 4 verse 3 decimal places? Right now we are finding the value, we're finding the cosine. We're still going to go to 4 decimal places. Alright, let's do another. That is a hideous number too. I'm so sorry you were subjected to that. Let's try again. The secant of 14 degrees, 18 minutes. Go into your calculator. What is secant? Oh, that's just 1 over the cosine of 14 degrees, 18 minutes. So 1 divided by cosine, open parentheses, 14 second apps degree, 18 second apps, number 2 for minutes, close it, and we get the decimal approximation of 1.0320. Kind of getting the hang of this? Alright, why don't you do numbers 3, which will be the cosecant of 70.2 degrees. Notice no minutes on that one. Number 4, which is the sine of 3.74 radians. Don't forget to check your mode. And last one for you to do is number 5, the cosine of 123 degrees and 48 minutes. Again, go ahead, pause this video, try these 3 problems on the calculator, come back, and let's check your answers. Alright, here we go. Number 3. That's 1 over the sine of 70.2 degrees, or approximately 1.0628 as a decimal. Don't forget the mode for number 4. Negative 0.5633. You better be in radians. And then you gotta switch it back to degrees for number 5. And the cosine of 123 degrees, 48 minutes. That is approximately negative 0.5563. And you should be all set. I had to double check number 5 there because it's eerily similar to number 4. But if you have any questions, come to class with them, and we will certainly do more practice with this. In the meantime, study for your uniform circular motion quiz and have yourself a great afternoon, evening, morning, whatever time of the day you're watching this. Bye.